When it says factor the common factor out, I am not looking for you to go any further than that, all right? So don't spend an hour trying to then factor it more. I'm really just looking for you to take out your common factor. I also want you to know that I have all the way up until that last section we did, so you are going to have to look and see if you can keep factoring when I say factor completely. All right, so the difference between this guy and the factor completely is I just want common factor here. When it says factor completely, I mean everything, even if you have special cases that you keep going. So just make sure that when you're doing this that you read your instructions. All right, for this one, we're going to look at common factor. When you say common factor, you're going to look at not only your numbers, but also your variables. So I'm going to look at 48, 40, and 72, and I'm going to say, what do I have in common? Well, as a number, I want my highest number that I have in common. What is the highest number that I have in common here between all of these? Yes. With variables, it has to be the same variable, but I want the lowest exponent because that's as many as any one can give me. So I'm definitely going to take x out, but how many can I take out? I can take out 4. And then you're just dividing. 48 divided by 8 is 6. X to the 8th divided by x to the 4th, you just subtract. I have 4 x's left. 40 divided by 8 is 5. I took out 4 of those x's. I have 1 left. 72 divided by 8 is 9. I took out all of the x's. I am done. When I say factor out the common factor, I don't want you to do anything else with this. This is all you're doing. You're done with this. For this one, you're going to break it down into your groups, your parentheses, okay? The first step is to look for a common factor. So when I look for a common factor, I'm going to look across it. If it starts with a 1, you're not going to take a number out. If you have extra variables, you may have to take those out. So in this case, 1, 16, and 60, I can't take anything out. I can't take a variable. Now I'm ready to start looking at factors of that last term. Remember, when it starts with a 1, I don't have to multiply across, break it up into 4. I don't have to do all of that. I'm just going to look for factors of 60 that will multiply to give me positive 60 and add to give me positive 16. All right? And if you don't know, if you get caught up, I just start at 1 and go down. So I'm like, 1 times what? Well, that would be 1 times 60. 2 times what would give it to me? That would be 2 times 30. 3 times what? Well, that would be 3 times 20. And I go all the way down, right? Until I get to something that gives me what I'm looking for. All right, so that's how I do it when I look for my factors. All right, I'm not doing a factor tree. I'm literally just doing pairs that multiply to give me 60, okay? Not doing a factor tree, just pairing up numbers that multiply to give me 60. And so once I find the 2 that I'm looking for that will add up to give me 16 and multiply to give me positive 60, that's actually all I need to know to finish out this problem. Now I know I'm going to say n plus one of those and n plus the other one, n plus 6, n plus 10. Or you could say n plus 10, n plus 6, but it's the same thing, all right? If you want to check these, you can FOIL them. And if you FOIL them, you should get what you started with. For the next one, if you have something that has 2, and 112, and I am the one that is giving you the problem, 112 should tell you that you probably have a common factor, right? I'm not going to make you multiply 2 times 112 and figure out those factors. So when you see numbers that big, something in your brain needs to go, I need to look for something in common, right? All right, if it's from me. If it's a standardized test, I can't help you. They may give you something big, but I'm not going to. So clearly you have something in common. These are all even numbers. What do I have in common here? Yeah, 2 can come out of all of these. So the very first thing I'm going to do is I'm going to take out a 2, and I have an x squared minus an x. Now this guy's a little bit big, right? What is he?
56.
Yeah, so this guy's 56. So he's a little bit bigger, but not too bad. All right. Now that I have the 2 out, this x squared minus x minus 56 is just like number 5. I need to look at factors of 56 that will multiply to give me negative 56 and will add to give me negative 1. So technically I'll be subtracting those terms because in order to get a negative, 1 has to be positive and 1 has to be negative, right? And so again, with 56, you can think about your factors. You can say 1 and 56, and you can go all the way down if you want to, right? Eventually, hopefully, you'll get to this guy right here, right? 7 and 8. You're looking for ones that subtract to give you a 1 now, since this is a 1. Specifically, I need one positive and one negative, and I need my answer to add up to -1. So which one of those is going to be positive and which one's going to be negative? Yes, -8, +7, right? And again, if this is a leading one that I'm factoring, I have my answer here. I don't have to break it up. I don't have to factor by grouping. I can go straight to my 2 parentheses. When you have taken out a common factor, that is part of your answer. So make sure you bring it down. And then you're just going to have a +7 and a -8. And again, you're done with this one. This is your answer here. Anytime you're factoring, when you factor by 4 terms, you do factor by grouping. But what is always, always, always your first step before you do anything else? Common factor, right? Yeah, so before we're going to pull it out and it'll be in parentheses, but then we'll group it. So we always want to look for a common factor. If you don't remember to take it out, at the very end, one of your groups will have a common factor that you can take out, okay? So if you look at these, they all end in 0s and 5s. What do I automatically know can come out of this? A 5, right? And it's possible that you may have something larger, but you definitely know a 5 will. All right, so when you're dividing by 5s and this big numbers like this, just do the first 2. 5 goes into 28 5 times. With 3 left over, 5 goes into 36 times. So when you're dividing and you have large numbers, just start with the little first part. 5 into 24 is 4, with 4 left over. These hopefully you should be able to do without using that method. All right, and so once you've taken out your common factor, 4 terms, you always just group the first 2 and group the last 2. Since this is a plus, I don't have to change anything, okay? Had it been a minus, I would have to change that last term.
Emily, Julian.
All right, now that we have this, we're going to look at each group individually. What out of 56 and 49, what can I take out?
7.
Yeah, I can take out a 7. What about my B's?
2.
I can only take 2 of them out. So I'm left with 56 divided by 7 is 8, and I took out 2 of my B's. 49 divided by 7 is 7. When I can't take anything out of a group like this, what do I write on the outside? A 1, because we don't want to forget that we have that 1 there. All right. When you factor by grouping, these should always be the same thing. If they're not, you need to check your grouping and your factoring. I pulled out a common factor that needs to be part of my final answer. List that first. Then you have your common group. And your second group is what's left over. This is going to be 7b squared plus 1. That is my answer. Like this, again, I'm going to say, do I have a common factor between 7, 10, and 8? I do not. Because I do not have a common factor and I do not start with 1, I need to multiply across and set up a 4 term. So I'm going to say 7 times -8 is -56. So I need factors of 56 that will subtract to give me 10. Factors of 56 that will subtract to give me 10. What are those factors?
4 and -14.
Yeah, so 4 and 14 are my factors. And again, if you don't know, go down 1 and 56 and just do all the way down until you say, okay, 3 doesn't go into it. 4 and 14. If I subtract 4 and 14, I'm going to get 10. And so the factors I'm looking for are 4 and 14. I need a -10, so this is going to be +4 and -14. When it's like this, then you're going to rewrite it to 4 terms, all right? And so I'm going to leave the first one exactly the same. 7x squared is going to stay the same. The -10 I'm going to rewrite to these terms right here. Make sure you put the x in there. So plus 4x minus 14x. It does not matter what order you write those in. You could have said minus 14x plus 4x. It doesn't matter. It will work out the same. And then you leave this one alone, -8. Now I have a 4 term. I'm going to factor by what method? Yep, I grouped behind a negative, so this needs to change. All right, it was -8. It needs to be +8. Between 7x squared and 4x, what can come out? just an x, right? So I have 7x plus 4. 14 and 8 have a 2 in common, 7x plus 4. Remember, when you factor by grouping, those should always be the same. So one of my groups is going to be 7x plus 4. The other group is going to be what's left over, the x and the minus 2. And that is my answer there, 7x plus 4, x minus 2. And so you need to pull a 3 out first, and then it's going to be exactly the same. That's still a pretty big guy, so I probably wouldn't give you even anything that big, 84. But 84 is not too bad. What factors of 84 will add to give you 19? 7 and 12. 7 and 12. Positive 7, positive 12. So I have 3 on the outside. I leave this alone. 2v squared. I change this to these two right here. Plus 7v plus 12v. I leave this alone. Plus 42. And then I'm just factoring by grouping, which most people do fine with. All right. 3 stays out here. I can take a v out. 2v plus 7. I can take a 6 out. 2v plus 7, which is how it should always work out. Don't forget your common factor of 3. Common group of 2v plus 7. And what's left over is v plus 6.
So how did you get 6?
Anytime you have two terms that are subtracted, you want to look for a special case, all right? So I'm going to say, is this a perfect square root? Yes. The square root of 4v squared is 2v. 1 is always a perfect root. The square root of 1 is 1. In this case, when it's two terms being subtracted, it's going to end up being plus and minus. So 2v plus 1, 2v minus 1. All right. 25 is also a special case, but I have a common factor. What can come out of 16, 16, and 4?
4.
Yeah, 4 can come out of all of those. And so I am going to first factor that out, 4. And then I have 4m squared plus 4m plus 1. And this special case is that this is a perfect root and this is a perfect root, right? What is the square root of 4m squared? 2m. Square root of 1 is 1, right? 2m times 1 doubled is my 4m. So that is a perfect square trinomial. When it's like this tells me what to put in between it, and I just square it. Don't forget you have a common factor that needs to go out in front. If you don't remember this one, you can say multiply across, factor by grouping, and all that good stuff. This is just a much faster way to do it. All right, so if you don't remember that, if you don't remember this, by the way, let's say you forget this one. You can say, well, that's the same thing as this. In fact, and you can multiply across and do them that add up to give you 0. And it'll work as well. So when it looks like this, there's a 1 in front. You're going to say factors of 45 that add up to be negative 14. And once again, you can list those if you want to. So you can say, oh, well, that's 1 and 45. That's 3 and 15. 4 doesn't go into it. That's 5 and 9. 5 and 9, those are going to multiply to give you 45. And if they're both negative, they will add to give you negative 14. Remember, you started with a 1 in front. So you actually have your answer here. But instead of saying x, I'm going to cut this in half, right? It's going to be x squared minus 5 and x squared minus 9. Anytime you have a higher exponent, you need to look for a special case. Are either one of those a special case? I have 2 perfect squares on one of those. Which one is it?
X squared.
This is perfect squares, which means I can break it down even further. This is done. So my x squared minus 5 is done. But because it's 2 perfect squares subtracting, I take the square root. The square root of x is x. The square root of 9 is 3. And I'm going to say x plus 3, x minus 3. You can keep going when you have higher factors there, when you have higher exponents. You need to look for special cases. What do you notice about 36? There's a common factor, all right? Which is, what is your common factor here? 4. Right, so I'm going to take my common factor out, m to the 4th minus 8m minus 20, all right? And then again, now that I have this, factors that multiply to give you negative 20 and add to give you negative 8, all right? What are those?
Negative 10, positive 2.
Right, so a negative 10 and a positive 2 will multiply to give you...
Negative am squared.
Yeah, it is a squared. Sorry, that's squared. We want to bring down that 4. We don't have to break it up into groups because it started with a 1. So 4, this is going to be m squared now minus 10 and m squared plus 2. This one is actually done. I can't factor this one anymore, right? Plus 2, if it's added, I definitely can't factor anymore. For the one that's being subtracted, 10 is not a perfect square root. So just because you have a higher exponent doesn't mean you're necessarily going to have a special case. You didn't have a special case with this one, but you do need to look for it and make sure.